Using the shape, composition, and decomposition skills acquired in earlier grades, students learn to develop area formulas for triangles and determine the area of quadrilaterals. This video will focus on MGSE6 G1. Find area of right triangles, other triangles, quadrilaterals, and polygons by composing into rectangles or decomposing into triangles and other shapes. Apply these techniques in the context of solving real-world and mathematical problems. In 4th grade, students learn and apply the formula of area of a rectangle. In 5th grade, students apply and extend understandings of multiplication to multiply a fraction or a whole number by a fraction. And in 6th grade, students find the area of triangles and quadrilaterals. They use formulas for area of triangles and quadrilaterals to solve real-world and mathematical problems. The ability to view a triangle as part of a rectangle composed of two copies of that triangle, coupled with the understanding that area is additive, provides a need for halving the product of the base times the height. This understanding helps students to minimize the chance of committing the common error of forgetting to take half when determining the area of a triangle. Corner of your rectangle to the other. And what do you notice after you've created that diagonal?
A triangle.
It's a triangle. How many triangles are inside your rectangle?
2.
And have we seen this before?
Yeah.
Where do we see this?
The square.
And the square. Wonderful. So now we have this idea that if we take the area of a square or the area of a rectangle and we cut it in half with a diagonal, we end up having a triangle. So what does that say about the area of a triangle? Who can raise their hand and tell me what they think?
That is half of a square or a rectangle.
And what makes you say that, Shannon?
Because when we put the line in the middle, it created two triangles for the square and the rectangle.
Okay, great, thank you. What were you going to say, Sierra?
We can do BH divided by 2.
Okay, and why is it BH divided by 2? So we have two different ways I'm here and we can write it.
Because the formula for a triangle is BH divided by 2. Because if you split a square and a rectangle, you get 2 triangles.
Okay, so it's like we're dividing it into 2 parts and we have those 2 triangles. I like that. So we can look at our formula 2 different ways. Area equals 1/2 the base times the height, or half the area of that square or rectangle, as Shannon said. Or we can divide the area of a square or rectangle by 2, as Sierra just shared with us. This task, Rectangle Wraparound, is in the Unit 5, Georgia Department of Education Mathematics Frameworks. It provides a hands-on experience for deriving the area of a triangle, as well as determining the area of a parallelogram by creating a rectangle. Also building on their knowledge of composition and decomposition, students decompose polygons into rectangles and special quadrilaterals into triangles or other shapes. This kind of decomposition is used to determine the area of the shapes, and it helps with justifying and finding relationships among the formulas for finding the area of different polygons.
I see rectangle, right triangle.
I see squares.
In the What's My Area task from Unit 5, 6th grade Georgia Department of Mathematics Frameworks, students decompose an irregular figure into rectangles, squares, and or triangles to determine the total area.
I see
Squares.
Square? Oh, yeah, square. It's off. Okay.
I see lots
I see
of
triangles,
triangles and
rectangles.
rectangles.
And parallelogram. What's a parallelogram?
Right there at the bottom.
Oh.
Is that a parallelogram?
I did not see one. I see 4. One for square.
So it's an measurement.
What?
And so tell me what you're doing right now, Shannon.
I'm multiplying 30 but times 10 because it said that it wanted it in millimeters and there are 10 millimeters in centimeter.
Okay. And so how are you finding the area of that triangle?
Do 30 times 20 and then divide that by 2.
Why do you think she's divided by 2, Jasmine?
If a triangle.
Mm-hmm.
And the formula is base times height divided by 2.
Okay. With assessment questions such as this, students find the area of triangles, quadrilaterals, and polygons provided in a mathematical problem. In addition, students will need to apply their understanding of composite figures to decompose and compose polygons into rectangles and triangles to solve for unknowns as seen within this example. Here, students may decompose this figure into a rectangle and a triangle. Using this decomposition, students would then need to subtract 60 and 5/10 feet from 75 and 5/10 feet to find the base of the triangle.